animals are what they eat. The lab-grown meat is also what it eats. We are scratching the surface on these phytochemicals.
Plant-based meat, grass-fed meat, what's the down low on the difference and the risks and benefits and the compounds in them?
Well, the headline is that plant-based meat alternatives and meat differ a lot in terms of their nutritional composition when you actually go beyond just the nutrition facts panel. So on a nutrition facts panel, say you're a consumer, right, and you pick up a package of the plant-based meat alternatives or meat, then there's about 13 nutrients that routinely appear on nutrition facts panels. These are things such as protein, fat, saturated fat, and a handful of vitamins and minerals. So there's a risk in that. Of course, this is good to give us an overview of what the food contains, but there's a risk in that in the sense that we can convince ourselves that that's all that food contains. But we know that foods in their natural state and the food matrix contain thousands of compounds that can potentially impact our metabolism and human health. So what we were interested in that work where we compared grass-fed beef and a popular plant-based meat alternative, the reason we chose grass-fed beef and a popular plant-based meat alternative is because they're both touted as more environmentally friendly and healthier. So when we did that comparison, we looked at 200 metabolites, and it is important to note, as you mentioned, Mark, metabolites are end products or intermediates in metabolism, we being the metabolism of plants, the metabolisms of animals or humans. And many, in the context of plants and animal sourced foods, many of these metabolites within the plant or the animal can serve as nutrients to us. So not all metabolites are nutrients, but all nutrients are certainly metabolites. So we studied that. Right. We looked at about 200 compounds in that. So it's a large number of compounds. And what we found is that there was a 90% difference in abundance of these compounds. So what that means was that of those 200 compounds, about 176 or so, they were either higher in the plant-based meat alternative or higher in the grass-fed beef. And in about a third of all these compounds, we could only detect them in either source. So they were only found in the grass-fed beef or the plant-based meat alternative. So what that study suggests is that when you take sort of a more in-depth or holistic approach to food, then meat and plant-based meat alternative are as different as you expect perhaps a plant and animal source food to be.
So, what I found striking was that, even though they kind of seem nutritionally equivalent, they were quite different in their metabolites. And for example, some of them in the plant-based meats were not in the animal meats, like some of the soy, for example, derivatives and phytonutrients. So, but sort of in a comparison way, were you finding that one was nutritionally superior to the other, or were they kind of not the same at all?
Yeah, that's indeed. I wouldn't say that one is nutritionally superior to the other. I mean, they both contain a similar amount of protein, and we have this hyper focus of protein. Protein is important, of course, the building blocks of our cells, but foods contain much more than protein. And what we basically found in the study is that we couldn't really say if one is better than the other. It would just mean that if you eat a plant-based meat alternative or if you eat meat, you get, at least on a sort of a bigger scale of nutrients, you get a very much different nutritional profile. You ingest different nutrients. So, and we know that the beef contains various beneficial nutrients such as taurine and anserine and creatine, which are important for our muscles, for our brain to function well. Then on the other hand, the plant-based meat alternative contained, as you described, a lot of phenolics, soy isoflavones, which could potentially lower our risk of chronic diseases as well, at least in what animal models would suggest and associative data would suggest. So there could be beneficial compounds found in both, but they were just different compounds.
It was interesting because you think on the nutrition facts label it looks the same, but on a metabolomic level, which is really the food as information idea, they differed by 90%, which is kind of striking. And there were many things that are really essential for human health that aren't in plant-based meats, like DHA, which is a key omega-3 acid, higher levels of vitamin B3, certain amino acids like hydroxyproline, antioxidants that are really important. And I think they're only found in beef. And when you looked at the plants, they also had some things that are not found in beef, for example, phytosterols and other antioxidants. So people think they're eating the equivalent of meat, I think, but it really may not be the same. And the question really is, what were the differences in terms of the anti-inflammatory and immune modulating compounds that were there? Was one more or less inflammatory than the other?
Yeah, we could not per se say this from this study, Mark, but there have been some randomized controlled trials done on comparing meat and plant-based meat alternative. One that pops to mind is from Dr. Chris Gardner out of Stanford. So he did a randomized controlled trial where he compared Beyond Beef and its products to grass-fed beef and organic pork. And what he found is that in the group consuming the plant-based meat alternatives as part of an omnivorous diet for, I believe it was about 8 weeks, they had a slight reduction in weight and a slight reduction in LDL cholesterol. He also measured 90 inflammatory markers, and he found no difference between the two. So in terms of inflammation, at least in sort of a randomized controlled trial, it would suggest that there's no strong health benefit over the other, apart from the reduction in cholesterol with plant-based meat alternatives. So what that tells me, Marcus, is that plant-based meat alternatives can be part of a healthy diet, I think. I also think meat can be part of a healthy diet, but the background diet in which you consume these foods are ultimately going to be the main dictator. And I think that's so important to remember when we have these discussions about single foods that make up just a small portion of our diet.
Yeah, I think that's a really important thing to think about. It's really what is the overall composition of your diet and what are you eating it with? And, a lot of the meat studies that show meat can be harmful are often done in population studies where people who are eating meat have generally bad habits because they think, the culture around us tells us that meat is unhealthy. So people who are focused on well-being and health tend to not eat so much meat. So it may not be the lack of meat that's the benefit, or the too much meat that's the harm. It's just what else they're doing. They're exercising more, they're not smoking, they're eating more fruits and vegetables, their weight is better, So there's a lot of other factors in these nutritional studies that are done epidemiologically. So I think the metabolomic analysis is very interesting. And then the question is, how does this affect human health? And are you aware of any data that looks at how these different metabolomic things affect human health that other than the ones you just talked about?
At the moment, we don't have much data on that in the context of plant-based meat alternatives. So obviously in the randomized controlled trials of, typically what they are anywhere from usually 4 to 12 weeks long. Sometimes you have major randomized controlled trials that maybe go out to a year. But presumably that is not really enough to cause micronutrient deficiencies, right? Which could be of potential concern. Again, coming back to the background diet, you can definitely, if you are very cognizant in consuming plant-based meat alternatives as part of a vegan diet, you could obviously, doesn't mean you develop nutrient deficiencies. But the point being here is that we see some, and we're doing actually a study now, Mark, where we're comparing grass-fed beef, grain-fed beef, or an Impossible Burger. And this is just an acute feeding trial, postprandial trial. So it means that we just pull blood for 6 hours after they eat that. Based on some previous studies that we've done in the past in my lab with different protein sources, you do see that. So we talk about the food metabolome, right? All these compounds that are in the food, but we also talk about the human metabolome. This is all the compounds and metabolites that circulate in our body. So by pulling blood for 6 hours regularly afterwards, we're now trying to find out, okay, in a very acute setting, if you eat grass-fed beef, grain-fed beef, or an Impossible Burger, which are all three different in the nutritional composition. Yeah. Obviously, the difference between an Impossible Burger and beef is larger. But you can measure what your blood looks like post-meal. I mean, there have been studies done that suggest that about 50% of what circulates in our blood, 30 to 50%, is directly related to the foods that we eat.
Yeah. And so what are they finding? I mean, is there things that they're discovering by comparing people eating an Impossible Burger versus a feedlot, industrial factory farm burger versus a pasture-raised grass-fed burger?
Well, we're about halfway through the study, so we do not have final results yet. So it always takes a bit for the
It's top secret.
Well, it's not top secret. If I had preliminary results, I would certainly tell you. But I don't have any results yet, other than we ask people, what do you think you ate? And how did you like it? And even those results I cannot tell you off the top of my head, other than just talking to our participants when they're in our clinical facility. But typically people can tell whether they're eating an Impossible Burger or beef.
I'm sure they can. Yeah. I think that this is going to be an exciting study. So we're going to make sure we link back to it in our newsletters and for sure put it in the show notes when it comes out. I think this is a very important study to be done, because it's one thing to look in a lab at all the metabolites. It's another thing to see how it interacts with human health. How does it affect our microbiome, our immune markers, our hormones, our brain chemistry? I mean, this is really interesting stuff to me. I think really, so you're saying they're not really nutritionally interchangeable. People shouldn't think of them if they're having like plant-based chicken or meat. It shouldn't be thought of in the same way as eating meat. And the nutritional profiles are different, even though they may look like the same on the nutrition facts label. So I want to talk about another study that you did that I thought was just so fascinating, which was kind of blew my mind. And Fred Provenza, who's been on the podcast, who I know you've worked with, and used to be at Utah State, is now retired, talks about the idea of the phytochemical richness of the animal's diet affecting the phytochemicals in the animal or in their milk. So a cow or a sheep or a goat or whatever eating a wider variety of different plant compounds, maybe over 100 different plants, sampling them, maybe some major ones as their main food source, but sampling a wide variety of plants has profound effects on the amounts of these physiologically active compounds that regulate our biology and our immune system. And basically, when we talk about food as medicine, this is what we're talking about. We're talking about the phytochemicals, the 25,000 different compounds that are in plant foods, but now they're finding them in animal foods. And I wrote a book called Young Forever. It's just out about longevity, and I went to the blue zones in Sardinia, and it was fascinating to me because they knew that when they take their goats or their sheep and they graze them on this plant or this other plant at this time of year, that it actually makes their meat and milk taste better. And I think most people don't realize that the taste of our food is directly related to the phytochemical richness of the food. And so we now actually can start to study that in ways that we didn't know. I mean, those Sardinian and Icarian farmers in Greece, they had no idea about phytochemicals. They just knew it tastes better. But what you're finding is that these compounds are in there. So can you talk about that study that you did and what you learned and the different kinds of things you found? Yeah,
no, that's a good point, Mark. And to your point, this is what kind of inspired us is those historical writings about especially French and Italian farmers that would herd their animals throughout these diverse landscapes. For instance, sheep farmers in Sardinia, and they were able to get different flavors in their milk and in their cheeses. And what they were really talking about there in that regard, they didn't know it was phytochemicals, but they just thought they tasted better, right? And what they're tasting is all these plant compounds that make their way into the meat and the milk of the animals. Now, when I started to look at this a few years ago, in looking at some of that older work that was done, 80s, 90s, early 2000s, by a lot of Italian and French scientists, they were just figuring out, how can we make this cheese better? I'm looking at this as a human nutrition scientist. I'm thinking to myself, hey, wait a minute. I know this from my biochemistry, that these also have potent antioxidant effects, anti-inflammatory effects, at least when looking at this in sort of a laboratory-based setting, right? Some of these compounds, when you put them on a cancer cell lining, they may have anti-tumor activities. Doesn't mean that per se the milk is anti-cancer. I want to make that very clear. But the compounds that are in there can have potential health benefits as part of an overall diet, right? So we took that work, and obviously fast forward 20, 30 years, we're able to look now at hundreds and thousands of compounds, or maybe in the past they looked at 10 compounds. But what we're seeing very clearly is that they have the saying, you are what you eat. Well, cows or sheep are what they eat as well. And probably even more so than humans, because they're grazing on a pasture and they cannot go through the drive-through and get other food, right? So we see this clear relationship between the phytochemicals in the forage on one hand, and that are then being metabolized and transferred into the meat and milk. And what is particularly exciting and unique about this is that animals can consume plants and grasses that you and I cannot consume. But we
Right.
know that these plants or these grasses, right, they might have certain medicinal effects or anti-inflammatory effects. So this is a way of getting those compounds in there. And one example I really like to use is with a farmer up here in Idaho. His name is Glenn Alzinga, and he kind of does what the Sardinians do. He herds his cattle through the mountains, and he moves them around on horseback. And it's very, very exciting because you're there and within the brittle lands, right, here out in the western rangelands. And you stand there talking to him, and then a couple of minutes later, the cattle are already gone. They typically graze a given field for about 2 minutes, and then they move on. So these are on public rangelands. But what's unique about that is that there are certain plants, and the farmer describes this much better than I do, but we know there are certain plants that if you and I consume them, we get sick. They're toxic to us. We get gut issues. But we also know these compounds, or these plants contain compounds that have certain medicinal properties. So by cycling these through the animal, this could be a way for us to get some of these compounds.
Well, that's fascinating. So what you're saying is there are all these incredible plant compounds that have medicinal benefits, but our bodies can't digest them. We can't properly metabolize them, but the animals, in a sense, upcycle them, process them for us. And there may be compounds that are not available to humans through eating their plant-based or plant-rich diet, but that can be obtained through these animals. And the question is, how significant is that? And are the levels of these nutrients at a level that make a difference for us?
Yeah, that's the $1 million question right now. So we do have 2 randomized controlled trials going on in my lab. One is indeed looking at grass-fed beef and grain-fed beef. So the grass-fed beef is also very biodiverse from biodiverse forages. So we know they're rich in phytochemicals. So we've also working on a big profiling study, which we call the Beef Nutrient Density Project. And what that essentially does is we look at 250 farms over a couple of years. We collect 3 steaks from them, and we look at the phytochemicals and other metabolites that are in there. We link it back to their grazing practices. So do grazing practices that are called quote-unquote regenerative or agroecological is the term I prefer to use, which is farming more in harmony with nature. So if we move these animals through the landscape, we don't overgraze, they're on biodiverse forages, we see that this results in more phytochemicals in the meat. So if we test a rich piece of phytochemical meat to maybe a feedlot meat that is not as rich in these phytochemicals, we know that the total mixed rations, which is corn and hay that the animals eat, they don't contain a lot of those phytochemicals. No. So we are so on paper, yes, the diverse fat grass-fed beef looks very phytochemically rich, about 3 to 10-fold higher in these phytochemicals than feedlot beef. But whether this has an appreciable health effect on humans, we don't know that yet. That's what we're trying to figure out in some randomized controlled trials.
And what's your gut feeling? You've been doing this for quite a while. What do you think we're going to see?
It's a good question, Mark. My gut feeling tells me that maybe in a laboratory-based setting we can measure that on very acutely. But I'm also a realist. If every fast food chain tomorrow switched out their feedlot beef with grass-fed beef, I don't think we'd get much healthier in society. So, coming back to the overall diet.
So you think because it's basically the overall diet, it's not necessarily the meat. So if you're trying to upgrade your diet, you can do it by eating pasture-raised meat, which has these phytochemicals and better fatty acid profiles and better amino acid profiles. But you really, what you're saying is you can't just eat that plus eat your processed food at the top of it and expect to be okay, which I think is obviously true for us to remember. Yeah, so we can maybe move the needle a bit, but as you describe, if we eat it as part of a ultra-processed standard American diet, then it's not going to cure our ailments overnight. So that's how realistic we have to be. But on the other hand, it is another way of further increasing the phytochemical richness of our diet, right? And increasing the potential health-promoting compounds that we get in. Now, in humans, it's notoriously hard to prove whether this is going to add X amount of good years to your life, and probably won't even be years. But
we do know that, okay, if we see that you have more of these compounds in your body, then maybe over 30 years, it could slightly lower your risk of chronic disease. It'd be hard to prove because we do 1,000 other things, right, to our health that could
It's
benefit
true.
or yeah.
Yeah, it's true. I think with our sophistication analysis of the metabolome and transcriptome, our DNA methylation patterns, biological age, they will be able to do intervention studies, controlled feeding studies in humans that can actually look at what happens when you eat different diets that include things like maybe you control for everything, but change from grass-fed to feedlot beef and see what happens. I remember one study I saw, and I mentioned this a few times on the podcast, that was in Australia where they fed people either kangaroo meat or feedlot meat. Because in Australia, you can buy like wild kangaroo meat in the grocery store. I guess they have a lot of kangaroos. and they found profoundly different profiles of inflammation in the group that ate the feedlot meat. They had more inflammation than the ones who had the kangaroo meat, even though they're eating gram per gram the same amount of protein. So I don't think it's insignificant. And I think, in Sardinia, obviously, and in Korea and many of the blue zones, there are many, many variables, but they're eating, lots of dairy products that come from these animals or having meat that comes from these animals. And I think that the quality of those nutrients are quite different. Like there's a very famous Spanish pig, the black-footed pig, which is raised in oak forests, and all they eat is acorns. And the fatty acid profiles, their effect on our lipids are quite different. Even the way we process meat and milk are very important. So I think we're going to learn more and more about this. I think you're one of the leading researchers and thinkers about this. I encourage everybody to check out your work, and we're going to post to all the scientific papers we've talked about so far in the podcast. But I want to dig into another one. And I want to talk about not just the human health benefits, but the broader context of ecological practices or regenerative farming or whatever you want to call it, and how those really are important too. So you're getting kind of, we're going to get into that in a minute, but I want to talk about this study that you did looking at the bison. It's kind of surprising because you looked at over 1,500 metabolites through very sophisticated analysis and found quite significant differences. This isn't looking at an Impossible Burger versus a cow burger that's pasture-raised. This is basically meat for meat. It's grass-fed versus feedlot. And so what did you find? And tell us about that study.
Yeah, so that study on bison was very interesting. So that was work that we did with the Turner ranches. And what was particularly nice about that work is that it was a very controlled study. And doing it on a commercial farm. So that was the nice part about it. So the bison, they were raised on McKinley Ranch in Nebraska, in the foothills. So it's a very biodiverse landscape. And then the bison are born there, and they do all the cow calving there. And then the animals were raised up until about 24 months. So they were all raised on pasture for 24 months. And then for 140 days or so, the animals were just run through a chute. If they walked left, they walked back into the pasture. If they walked right, they walked into a feedlot, essentially. So it was randomized. And then the animals were finished for 140 days. We got the meat, the strip steaks, and we analyzed those for metabolomics analysis to look at, okay, does this alter the nutritional profile? And what is really nice about the metabolomics analysis, Mark, is remember that I said earlier that not all nutrients are metabolites, but all metabolites tell us something about metabolism, right? So yeah. Studying this, a bison is a mammal, just like you and I are. And you can find a lot of parallels between the metabolic health of a bison and a human, these pathways. So let's talk a little bit later on the metabolic health of the animal, because that I can say something pretty definitively about. But if we looked at the nutritional profile, we found that the phytochemicals were about 3 times higher in the animals that stayed on pasture for 140 days. One important thing to note, though, is that the Turner ranches, they, finish the animals in a feedlot. At least half of their operation is that. But their feedlot is not your typical feedlot, because the animals there, they have more space. They're in loose confinement, so they have about 4 times more space than typical. And normally animals are fed a total mixed ration. It means that everyone gets the same thing. It's like a military ration or a ration in prison, right? You can't choose. But what the animals got, they could choose from hay, alfalfa hay, meadow hay, which was the hay from the pasture, or corn. And they could choose that in sort of a buffet style. So they could regulate how much they eat of all of those.
Buffet.
And a buffalo buffet, yes. I mean, it's and a surprising, Mark, is that they went for the corn quite a bit. Like about half of their intake came from corn, but corn to an animal is kind of like candy, right?
Of course.
If we go to the buffet, we also if we have a bunch of ultra processed foods and peas, then we might select, even though the peas are better for us, we might select the French fries, right? To a large extent. So. But we did find differences. So 3 times more phytochemicals on the grass-fed animals. Also, a few B vitamins such as vitamin B5 and B6 that we know are in grains were actually higher in the feedlot finished animals. Vitamin B3 was a little bit higher in the grass-fed animals because we know fresh forages provide those precursors. But what was particularly interesting, if we look at an omega-6 to 3 ratio, so omega-3s are fatty acids that we know have various health benefits. This ratio of omega-6 to 3 tells us something typically about the nutritional quality of the animal source foods or the healthfulness. I think it's a relatively solid biomarker of that.
Yeah.
So closer to 1
what was the difference?
Means,
was it like a significant difference, or was there just a slight difference?
It was a significant difference, but it was slight. So the feedlot bison had an omega-6 to 3 ratio of about 4. The pasture finished bison had an omega-6 to 3 ratio of about 1.5. So it contained more omega-3s, and typically those are amongst the best ratios that you see.
Yeah, so from 4 to 1 to 1.5 to 1. That's pretty significant.
Yeah, so from 4, indeed. But here's the sort of the bigger picture of that. We've also tested a lot of grass-fed beef, about 60 to 100 farms. The average in the grass-fed beef industry is 3. So the bison were only 1 point worse than that. And I would still consider an omega-6 to 3 ratio of 4 to 1, which was in the feedlot bison, to be very good. Because we know that probably our historical intakes in humans was about 4 to 1, 5 to 1. And so... And feedlot beef typically has an omega-6 to 3 ratio of like 12 to 1.
12 to 1. Wow. So basically feedlot cow eating corn and grains is 12 to 1 omega-6 to 3. That's significant.
Yeah. So the bison, the feedlot bison, while they were different from the pasture-raised bison, if you look at it in the bigger picture, they still had a very favorable omega-6 to 3 ratio. And the difference were also not as large as we sometimes find with feedlot beef and pasture-raised beef. But we are finishing up the study or following up a study with multiple arms, because even in the bison industry, total mixed ration feeding is more common. So the turners, the way they finish in their feedlot, it's a little bit different from what the rest of the industry does. So I could imagine, my hypothesis will be for the next study that if we feed the bison total mixed ration, that the difference is going to be bigger.
You mean so the way the Turner Ranch does it is better?
Yeah, indeed. I would argue that what they do is it results in a better nutritional profile than what would typically happen in a feedlot.
And can you talk about the phytochemicals? Because I think that's really important. And are these meaningful levels of phytochemicals that are in the grass fed as opposed to the feedlot bison?
Yeah, I do think they are meaningful, Mark, for this reason. Is that I do want to say, of course, a carrot is going to be a way better source of beta carotene than grass-fed bison is. But we do find certain compounds like catechins, ferulic acid, which are major polyphenols, hyporic acid, in relatively high quantities. So we, for instance, did some comparisons also looking at, well, let's say if we have catechins that are in green tea, for instance, which we think are part of the health benefits of green tea. If you study that in milk from very biodiverse animals, then about a cup of milk and a cup of green tea, I must say this, the green tea that's at the lower end of the spectrum, they can start approaching each other. So
wait, you just said that basically if animals are eating the right plants, they can have as high levels of these protective phytochemicals we find in green tea called catechins as green tea itself. That's a big statement.
In the worst green tea. In the worst green tea. Well, it's a big statement. That's why I try to bring it carefully. But because we know that probably the overall phytochemical richness of green tea, I think is going to be a lot higher. So, but certain individual compounds can be found in meaningful amounts. That's my point here. But as I said,
that's amazing.
But eating, quercetin from onions is probably is a better source of quercetin than maybe the grass-fed beef. But the point is that it is a way of further increasing the overall phytochemical richness of our diet. So
you said something really interesting before, sorry to interrupt, but you said that there are certain compounds that we can't get from plants because our bodies can't process them that we do get from animals. And we're still learning what those do and how beneficial they are. But it's very likely that there are compounds that are in meat, for example, that are eating a wide variety of plants from animals that are eating a wide variety of plants that actually have higher levels of compounds levels of compounds we can't actually get from plants.
Yeah, I think that's the best way to describe it. Best way to summarize it, Mark, is that some of these compounds, we know certain terpenes that we may not per se get in our diet that are found maybe like sagebrush and things that we do not consume. Then we see those appearing. So I think that's the key part is that, okay, we can get certain unique compounds, and the compounds that we are getting in terms of certain phytochemicals, eating it as part of pasture-raised meat is a further way of increasing it, right? Like one analogy I like to use, Mark, is that zinc from animal-sourced foods, yes, they're more bioavailable. They're higher in zinc animal-sourced foods, but plants can still make a meaningful contribution to our overall intake of things like zinc and iron, right? And if we think of it as the reverse with phytochemicals, of course, plant sources are going to be our primary source of phytochemicals, but animal source foods can add additional phytochemicals that we get to the plants, plus likely add a few unique ones. And I think that's the key message.
That's quite amazing. And what you were doing was comparing kind of bison to bison, not like grass-fed bison and pasture-raised bison to feedlot cows, which may even have a much bigger difference, right?
Yeah, indeed. I mean, we've done comparisons also, similar analysis on the bison and as we do on the cattle. So while, they weren't in Nebraska per se raised, right, the cattle, but we can do if we do similar analysis, you can do some qualitative comparisons and some rough comparisons. And what we do see is that you have pasture-raised bison here, which is probably similar as the best pasture-raised beef. Then you had the Turner Ranch's feedlot bison that kind of falls in the middle. And then you had the feedlot finished beef that was probably the least nutrient densities phytochemicals. But I also want to say this, Mark, is that we're painting with broad strokes here, right? Feedlot beef isn't feedlot beef isn't feedlot beef. Even amongst the feedlot beef industry, we find a threefold difference. I mean, if you feed potato peels or almond hulls, we know those are rich in phytochemicals, these byproducts. So they can increase the amount of phytochemical richness even in the feedlot. And we're doing some work. Yeah, we're doing some work right now with chicken, for instance, where they feed a small amount of like grape hummus or alfalfa. And that does make a difference. So
yeah, it's true. Although I remember reading about this big truck that kind of had an accident on a major highway. It was filled with expired Skittles, and they were on their way to feed the Skittles to cows. I thought, okay, well, those are colorful, but they're not exactly phytochemicals. That's pretty funny. So I did notice something. This is a little geeky, and I just want to bring it up because I sort of noticed it. There's a fatty acid called C15, and it's kind of emerging as a really important fatty acid. It comes from animal fat. It's a saturated fat from dairy and animals. And it seems to be higher in grass-fed beef. And C15 has all sorts of health benefits. If people are wanting to learn more about it, they can go to Discover C15, the number 15, discoverc15.com and learn more and read about the science of this. But it's quite interesting. And I thought, wow, it seemed to be meaningfully more in the grass-fed bison, pasture-fed bison than the others. Can you talk about that a little bit?
Yeah, absolutely. Yeah. So C15 is a dietary odd-chain fatty acid that was mainly studied in the context of milk, but it also appears in ruminant meat. Say, for instance, with CLA, which has been studied in dairy and is another fatty acid with potential health promoting compounds. So, yeah, we found higher amounts of those. I think it was about twofold higher by head. So we found higher amounts of C15 related, we think, to the forages. In the next study, we'll also be testing all the forages for the fatty acid profiles. And one other thing that we found, Marcus, is very interesting, is that we think of saturated fat as sort of this category that is all-encompassing, right? And we think saturated fat is bad for us, and will be a long, nuanced discussion, which maybe we won't get into. But it's a little bit more gray than that, I'd say. But then usually a question I have is that, well, what type of saturated fatty acid, individual fatty acids are we talking about? Because we know certain compounds are associated with, are more neutral for our risk of heart disease. And some of them might even be protective, which are the long chain saturated fatty acids. So this is behenic acid, arachidic acid, nonodecanoic acid. So basically C20 and up, but C15 also seems to have some potential health benefits. But we know that people with higher amounts of these in their diet or circulating in their blood, that's associated with a decreased risk of heart disease. And I think this is also what was a key finding of our paper, and I think is not as recognized as much, is that you improve the saturated fatty acid profile too, even though the total amount of saturated fat between the two products is the same.
It's interesting. Yeah, you mentioned in your paper that the cardiac risk may be different because, we think of all meat as being bad for your heart, which is not actually true. But in the grass-fed meat, you had higher levels of, we call fatty acid glycerol or fatty acylcarnitine, which are actually metabolites that are reduced in grass-fed meat compared to feedlot meat. So that actually is it's a little technical, but it's a beneficial fatty acid profile of the meat that actually is more protective than a feedlot meat for your heart.
Yeah, on paper, it certainly is more protective. And one thing we could say, it was certainly protective to the bison, because while we do not know exactly what the effect was on the metabolic health of the human yet, until we finish our nutritional studies, but what I can say, and I feel comfortable in saying, is that, the pasture-raised bison look metabolically healthier. To use an analogy, Mark, is that the pasture-raised bison, they kind of look like a human cyclist or an endurance runner. And the feedlot bison, they look more like maybe a sedentary person that doesn't walk as much, and maybe their diet is also not as good. And this is in comparison to each other. It's not to say that the feedlot bison is unhealthy for you, but if we compare the two on a relative scale to each other, then yes, the pasture-raised bison, they have a better athletic phenotype. They rely on mitochondrial metabolism instead of glycolysis. They also had lower amounts of advanced glycation end products, and lipoxidation end products. So 4-HNE is a compound that's been very well studied, and it is associated with a whole host of ailments. Right? It's one of the reasons why red meat is considered a potential carcinogen. And we know these AGEs and ALEs, these advanced glycation and lipoxidation end products, they're related to glycation, sugars, and they're related to lipid peroxidation, so oxidation of lipids. So if we look at, for instance, the glycation, if an animal has a worsened glucose metabolic health, just like we see in humans that potentially have prediabetes, for instance, these glycation end products, they are related to the glycation of the sugar. So if the animal has more sugars in its body and does a poorer job of metabolizing them, we start to produce more of these glycated end products. So we can already
Yeah.
see that this is animal health. The animal's healthier, but we also know that we are then exposed to lower quantities of these things in meat that we think are bad for us.
That's incredible. I want to break that down because it was a lot. I understood it because this is what I've been studying my whole life, but I don't know if anybody else got it. But basically what you're saying is that these feedlot bison that are eating grain are pre-diabetic and they have more inflammation in their system. They have poor metabolism. They have more oxidative stress. They have like toxins like this 4-NE, which is this, this derivative of basically the oxidative stress byproduct. They also have higher levels of what you call advanced glycation end products, or AGEs, or AGEs, which drive inflammation. It's just what you see more in diabetics, why you get cataracts and heart disease and all kinds of stuff. So basically the animals eating the kind of diet that most of the meat in this country is fed, basically grain-fed feedlot meat, are very poor in poor metabolic health. The question that comes up in my mind is, what happens when we eat a diabetic buffalo or a diabetic cow? Does that affect us? And I think what you're saying is it does.
It could. I'm not 100% sure. I mean, the two things. The animal doesn't get, it's rare to see diabetes in bison and cows. I also don't know what the sliding scale is here, Mark, because we know, as a human, when you're at
being
least,
very generic, but right. Sure.
Yeah, generic. It's good. But because we don't know, we don't have hard cut of, okay, here is when an animal has pre-diabetes or something like that, right? We don't know that. What would be interesting is and I kind of want to do this in a study, and I'm not sure what we know across mammalian species, and this is something I've been pondering for a while, and I think we just have to do it. What if we take blood or muscle from people that we know have diabetes or pre-diabetic, and what if we take it from runners, endurance trained athletes? What is the difference? Are they threefold more metabolically healthy? Are they fourfold more metabolically healthy? And then do the same thing from feedlot animals and pasture-raised animals, because then we can get a feel for what it means on a scale. Because it could just be that if you have, on the other end of the spectrum, you have diabetes, and the other end of the spectrum, you have like great metabolic health, that the feedlot animals are still pretty good, right? And that I don't know yet at the moment.
But it's fast. I mean, just on an intuitive level, intuitively, it seems to make sense that if you're eating an animal that's not that healthy, it's going to affect your health, right? That's basically what you're finding. That these animals are less healthy.
That's a valid hypothesis.
Yeah, interesting. Well, it's so interesting. I was thinking about the Plains, the Native Americans that lived the Lakota and a lot of the Plains Indians around the turn of the century. They had the highest levels of centenarians, of people who lived to be 100 at the time. And I thought that was interesting because their primary diet was grass-fed bison, basically free-roaming wild bison. And they were eating a huge variety of different plants, and they were eating it from soils that were quite different than the soils we're actually eating. So I wonder, how much not only what the animal's eating, but the agricultural land and how healthy that is, and the phytochemicals in the plants that actually are higher amounts in land that's in better health. So basically, if you have healthy soil, healthy land, and plants grow in that soil, they're going to produce more of these phytochemicals. The animals are going to get more, and we're going to get more. Is that a valid way of thinking about it?
I think so, Mark. I think that's a valid way of thinking about it. We do know that indeed from the soil to the plant to the animal, I think we are starting to well establish healthier soils that are more nutritious. They result in more phytochemicals in the plant, and there's also a symbiotic relationship there, right? Because if you have healthier plants, also is able to improve the soil health, especially biodiversity seems to be important. And then we also have the animal on the other side, right? That also plays a symbiotic role by consuming the plants. It's a healthy stressor for the plant when it's not overgrazed. So it renews itself. It responds with these phytochemicals and things like, hey, wait a minute. I don't want to be consumed by this bison again. So I'm going to up these phytochemicals, right? And then, so there's this whole sort of adaptive and mechanism and this evolution that happened over many years between herbivores and plants that could have benefited both. Then we get to the human. it becomes a little bit more tricky. We're the ones who usually take and don't give back as much, right? Because the animal puts urine and manure back into the soil and improves again, hopefully the plant and the soil. But what we're seeing there is key is that yes, if you get healthier soils, if you can grow more diverse and healthier plants, then yes, you'll end up with a healthier animal that is more nutrient dense.
Yeah, I mean, you really are studying the intersection between soil health, animal health, and human health, right? They're inseparable. And the healthier the soil and our agricultural lands, the healthier the animals, the healthier we are. And I think this is something we've kind of lost. And we think we can just have lab meat. I wonder what you think about the lab meat, because it's really blowing up. And I think I want to talk about that in a minute. But this sort of intersection of how we grow food and how what are basically the food our animals are eating or the plants are actually, the soil is giving them, that really drives our human health. And I think this phytochemical richness of our diet is really dependent on the health of the agricultural environment, which is really dependent on creating an healthy ecology, not having these giant monocrop agricultural systems that are growing one crop, spraying with pesticides and herbicides, destroying the soil, and having to put fertilizer on to grow things. And kind of we're missing the boat on just the nature of nature, the nature of ecology, and how the ecosystem has to be healthy to create a healthy plant, to create a healthy human, to create a healthy animal, right?
Yeah, no, it's so important, Mark, and I agree. Is that intuitively that relationship makes a lot of sense, and when we study this in our lab, then yeah, those things do become very clear. And to your point about the lab-grown meat as well as field-grown meat, is that animals are what they eat. That is very clear. What we're seeing, the lab-grown meat is also what it eats. In other words, what you throw in the growth media, right? So there may be advantages that we can, for instance, increase the amount of omega-3s in lab-grown meat. I'm just, thinking sort of out of the box here. But we are scratching the surface on these phytochemicals. Yeah, we studied maybe 100 or 500, but they probably contain 70,000 of them. And we have no real clue exactly what they do. So I think that part, that incredible phytochemical richness, that antioxidant richness, might be hard to replicate when we have lab-grown meat, right? In cellular agriculture, because how are we don't fully understand what's in the plant and how it ends up in the animal. So provided that because we don't know that, right? What do we put in the serum media, and how do we know if it's being uptaken, right? But I think the main thing is that we don't exactly know what to put in there to replicate all these flavors and all these phytochemicals.
Well, that's a whole fascinating idea. I mean, yes, you're feeding it the basic components to provide nutrition for the meat to grow. And by the way, that much of that comes from industrial farming of soy and corn and other things that they're feeding the lab-grown meat. So that's a whole nother issue of where the raw materials come from to feed it, because you still have to feed it in order to grow it. It's not just growing out in thin air, but it's what we don't know that's the problem. We don't know what we're not giving this lab meat in terms of the phytochemicals. And there, like you said, there are tens of thousands of these things. What is their impact on human health? How do they play a role in our real well-being? And if they're missing, what do they do? Or what do they not do for us? So I think this is kind of really interesting stuff, because the whole meat conversation is so monolithic. It's like meat is bad, plants are good, and it's just so much more nuanced than that. There's lab-based meat, there's feedlot meat, there's grass-fed meat, there's plant-based meat. There's a lot of different things going on, and there's a lot of different elements to each of these and what makes them good or not so good. So I think the work you're doing is so important to help us tease out these answers to these very complex questions. And I think they'll have a lot of implications for how we shift our agricultural systems, for how we maybe create policies to support different ways of growing food, to policies of what's healthy for you, what's not healthy for you. So I think it's kind of exciting. And I wonder, you seem to be kind of one of the few people doing this. Are there other people working on this as well? Because I know Fred Provenza is retired now and he's great, but you're kind of in the trenches. Who's your colleagues out there, and who should we be looking to for more information about this?
So certainly we're working with other groups as well who are doing this, and I know other colleagues who are doing it in other countries as well. For instance, we've collaborated with a great scientist up in New Zealand. His name is Pablo Gregorini, and he's been doing this a lot in New Zealand. Has a big grass-fed industry, right? Grass-fed beef, grass-fed lamb.
In New Zealand, yeah.
And so we've been doing work. We have done some work with him, and he's also doing a lot of his sort of, he's able to build that line of research up himself as well, comparing the phytochemicals in the forage to what ends up in the meat and milk in New Zealand. Then they're, like I said, they're French scientists within the USDA equivalent in France who are doing some of this work, and then they've done it for many years in cheeses and are indeed doing more work into that area. So the phytochemicals in the cheeses, they usually look at that from a flavor standpoint, but flavor and health, the two are connected because these flavor compounds or the phytochemicals, they also have this health effects. And then here we are working with various groups in Michigan State University. We have a collaboration. With some folks in Cornell that are feeding different types of forages to cattle or to dairy cows, I should say. And we're trying to figure out, how does that impact the phytochemicals and the antioxidants and potentially these flavor compounds in the milk? So, yeah, it's certainly a very interesting time. And what it kind of reminds me of, Mark, I'm teaching a course now, micronutrient metabolism. We dive a lot into sort of the history of vitamins and how these were discovered, right? And we didn't know a lot of things. And what's interesting, a lot of these things, and I see a lot of parallels with the phytochemicals and the vitamins 100 years ago, is that, we're kind of starting to discover it. We're kind of starting to learn what they do, but we don't fully understand yet. And probably takes another 50 years to isolate all the structures of these, right? Because people knew that if you had a thiamine deficiencies in the 1800s, that you get beriberi, right, and that you have that you get pellagra from vitamin B3 deficiencies. They saw that, but it took another 50 years to figure out which compound that was and what was responsible for that. And I see a lot of parallels with that now, where we think like, wow, what do these phytochemicals do? They seem to be having health effects. We don't fully understand them, but they seem to be important. So that's why I also always err on the safe side. And I'm a little concerned when people say like, these are secondary metabolites. They're not that important. Because I think that in 50 years, I don't want to be the guy who said, beriberi has nothing to do with diet, right? And then 50 years later, everyone accepts it has to do with diet. So that's why also with phytochemicals, maybe sometimes now when people are a little bit skeptical, I'm always like, well, we'll see in 50 years. But it does seem that, at least for animals, it seems to have anti-inflammatory effects. And I think in humans, there's definitely some data now out there too that suggests that things like flavonols and polyphenols have anti-inflammatory effects for us.
Yeah, I think that's such an important comment you made. I want to kind of loop back on it because it's something I was thinking about as you were talking. I'm like, back when we refined white flour, we refined rice, we thought this was a more refined way of eating, but then all these very serious, often deadly diseases like beriberi, pellagra, actually started to emerged because of vitamin deficiencies, because we took away the whole grain, we made it refined grain, and then we had to add them back. That's why we call it enriched flour. It's only enriched because we impoverished it by refining it. And that's kind of an amazing thing. And we didn't even know these were important. And the same thing, I think, with these phytochemicals. I don't see these as sort of secondary anything. I think these are critically essential to thriving. And, I just sort of finished writing my book, Young Forever, about longevity. And it just was amazing to me, the science of these phytochemicals and how they affect very many of the important pathways that regulate health and disease, particularly longevity. And they bind to different receptors. They regulate our immune system. They regulate mitochondrial function. They regulate our ability to repair our DNA. And I could go on and on and on. So I think, these are medicines, and they are part of our food, and they're probably just as important as vitamins and minerals. And maybe you won't get an acute deficiency if you don't have it, but you will get a chronic disease and you'll die sooner for sure.
I think that's a great way of summarizing it, Mark. That's my hypothesis too about phytochemicals. Yes. I enjoy the work very much. And I want to say this final piece is that I'm very grateful for the farmers that are doing these things on the ground, because I sometimes jokingly say is that in our work, what we're doing is we're verifying a lot of farmer knowledge, what farmers already see, right? They say, well, Stephan, when I do these grazing practices, my forages look better, and I've noticed how healthy my animals look. And then I'm just taking those forages into my lab, we're taking the meat or the milk into our lab, and we're analyzing that. And I'd say almost always the farmer is right. And they were like, yes, what you see day in and day out by just observing your wisdom, we see in our science as well. And I think that's so important always, is that as a scientist, of course, I have scientific findings to, we put them on a pedestal, right? And I think that's very important. But I think we should also encourage and recognize what is wisdom. And wisdom amongst farmers and indigenous populations that have managed these lands well and are seeing these things. So I think that's such an important key part is also. And yeah, I always encourage people to get more connected to their farmer. If you can get some of your meat, milk, and eggs from your local farmer and become connected to them, learn how the food is grown, I think that is valuable in so many ways. It's appreciating the food, appreciating the life of the animal that has provided you with this food, and to become really connected with it. And I think you also have a skin in the game, right? If your farmer a couple of miles from you is doing the right thing, is regenerating its ecosystem, it's also nice for you to see, right? Rather than having a slush pit down the street or something like that, right? So I think it's even if the health effects, we don't have all the data right now if it's truly healthier, but I think it does have the potential to be beneficial on so many levels.
Well, it just makes sense. It's good for the planet. It's good for the animals. It's good for humans. And I think that's the bottom line. If you love that last video, you're going to love the next one. Check it out here.
Put that wrong fuel into the engine, and now you squash the human metabolism as well. This is actually a eureka, because now we've taken it way far away from calories in, calorie out.
Yeah.
What we're saying is that